Hello, Precalculus student. This video is for Chapter 1.1, Part 3. We will be going over how to evaluate a function expressed in a formula, like application of it, and also go through one-to-one function and ToolKit function. But there is a example that I did not cover when we do function notation, and this is find the difference quotient of a quadratic function, x squared minus 3x. So I want to finish this example first before we go over the other topics. So a difference quotient is, by definition, is f of x plus h minus f of x. So it is used widely to define what is a derivative function in calculus. So you'll come across this in the beginning of calculus. So we'll teach you how to evaluate them now. So this is the definition of difference quotient. Whenever people say, find a difference quotient, that's basically what it means. So our function is defined as x squared minus 3x. So every time I see x, I plug in x plus h. So this would equal to x plus h squared. Remember, I have to FOIL this, minus 3 of x plus h. So that is the first part. And then I minus the function itself, which is just x squared minus 3x. And remember to parenthesis it, and then all divided by h. Now we want to simplify by combining like terms. So x squared plus h, x plus h squared is x squared plus 2xh plus h squared. 3x plus h would be minus 3x minus 3h, and then minus x squared minus 3x is minus x squared plus 3x. And you can see that this 3x and this 3x goes away, the x squared and x squared goes away, and all over h. So not enough space here. So we would say we have what? We have 2xh. We also have h squared. We also have minus 3h left over all over h. Now all of these has nh terms, so we factor h out, and we have 2x plus h minus 3, right, over h. X and x cancel, so the final answer is 2x plus h minus 3. And that's the difference quotient for x squared minus 3x. So we end up having a different another formula, but this formula have x as well as h. So the next topics is if I have some formula and I want to write it as a function for application. So whenever you have a formula that relate two variables, and if you have decided which one is input, which one is output, you would want to solve for y equal or the output equal to the input. So for example, I have a formula that is 2x plus 6p, 2n plus 6p equal to 12. I want to write a function f of p as a function of n. So look at this statement. P as a function of n means p is the output. That means you want to write p equal, right? And then n is the input. So you want to write p equal to function of n. So this side is a formula of n. So if the formula is given like this, so what you want to do is keep p on the left hand side. So you will have 6p equal to 12 minus 2n because you subtract it on two sides. And then you want to get rid of the 6 also by dividing. So it'll be 12 minus 2n divided by 6. So that is a function. And so this is a formula. In function notation, you will say f of n, p is f of n, right, is equal to 12 minus 2n over 6. And that's how you write it. You can write it as p equal this, p equal like that. The second one is they have a function that represents cost of catering n guests. So n is the number of guests, c is the cost, right? So you write down c is cost, and your input n is the number of guests. So someone writes c of 12 equal to 180. C of 12 equal to 180. That means this is the cost and this is the guess, right? Oh, So the cost, you would write the meaning is the cost of catering 12 guests is $180. Express the radius of a circle as a function of the circumference. Radius of the circle as a function of circumference. So what do we know about the formula between circumference and radius? We know circumference is 2 pi r, right? This is a formula that is known. Now we want to use it and write it as r as a function of the circumference. R is the output, right? Usually we write circumference is a function of r, but now they want it this way. So you would say r is equal to c over 2 pi, because in this formula, if you divide 2 pi, you have r equal. So you would say, write as a function notation, you would say r of c is equal to c over 2 pi. Okay, explain the meaning of r of 8 pi equal to 4. So that means when circumference inside, right? Circumference is inside, is 8 pi, radius is 4. So it's like your circumference is the input, and you use it to find the radius. R is equal like this. So it doesn't have to be a function name. You can use the same variable as a function name. Here, the fourth one is I have a formula x equal to 3y cubed equal to 0. We want to write y as a function of x. That means we want y equal, right? So x, put y on x and y on the two different sides. X would equal to 3y cubed. Switch them around. 3y cubed equal to x. Y cubed would equal to x over 3, right? And I want y. So how do I get rid of the cube? I do cube root. Cube root, if I do cube root on both sides, so this and this cancel, this would become a cube root. So cube root of x over 3. So this is a function. So you say y equal to f of x equal to cube root of x over 3. You can input x and you get the function y. Our next topic is one-to-one function. So there is some function that is special in that we'll talk about this in 1.7 because they are one-to-one, meaning every single x corresponds to one y. A which corresponds to B, and they don't share any numbers. So we call this one-to-one. Basically, that's what it means. And to check if it is a one-to-one, in a graph, we use something called a horizontal line test. Vertical line test, check if it is a function. Horizontal line test, check if it is a one-to-one function because there's no sharing of y. Every x would have a different y. So let's do this example. So I have a order pairs list. You can think of it as a table, x, y, where you have 2 is related to 3, 4 is related to 5, and 6 to related to 7. Is this one-to-one? Yes, there is no sharing of y. Every different x would have a different y, so yes, right? So just check that. If it's a graph, how can I determine it's a one-to-one function? So these are all functions because when we do vertical line test, it works. And then we'll check horizontal. Oh, there's 2y that is the same for different x. They are sharing the same y, so this is not one-to-one. When I do horizontal, these are all 1 point, so this is right, and this is all 1 point, so these are all okay. So in all horizontal line hit the point in 1, then it's a one-to-one function. The last things we want to talk about is family of functions. Very popular, and it is kind of like the building block. Kind of like when you study numbers or the digits 1, 2, 3, 4, 5, 6, 7, 8 are the primary numbers. So for functions, which primarily are formulas and relationships, these formulas are the basic that we can form other functions. So so you need to know the name, you need to know the formula, and you need to know the graph. Okay, and we also have several key points that is important in the graph. So the first is, so it's kind of small. I'm going to blow it up a little bit here. The first is a constant function. It's just a horizontal line. Y is equal to c. Okay, so in this case, it's y equal to 2, right? Because it goes through y equal to 2. The second one is called identity function, where all the points x and y are the same. So 1, 1, 2, 2, 3, 3, -1, -1, -2, -2. So the equation is y equal to x, and in the function notation is f of x equal to x. The third is called absolute value function. It's very similar to the identity function, except your y is always positive. So it's an absolute value of the input. So you would have 1, 1, 2, 2, but when x is -1, your y is still 1. Okay, and the shape is like V shape. The third is quadratic function. So if you study algebra or intermediate algebra, you should have come across this. This is the basic quadratic function. The formula is y equal to x squared. So basically, it's like a parabola, very similar to the absolute value function, except it's not a V shape, but it is a kind of smooth parabola. The third is a cubic functions, is y equal to x to the power 3. So it is a kind of like a S shape where you have 1, 1, and -1, and -1, but it's not like a line, but it's like that. The next one is called reciprocal function, is y equal to 1 over x. So it is a function that has two branches. So on the first quadrant, you have 1, 1, and then you have the 1/2 and then 2, right? So if you plug in 2, your y is 1/2 because it's 1 over 2. So all those points, remember there's two branches, and also because there's no dividing by 0, so when x is 0, there is nothing. Okay, so the point does not have any y value. The next one is reciprocal square function, is f of y equal to 1 over x squared. So basically it's also two branches, but because after you square your x is always positive, so it's kind of going up like that. Now, although the two branches go up to infinity, but they don't meet at infinity. So at x equal to 0, it will be also undefined. The next one is called square root function. Basically, y is square root of x. If your x is 4, then square root of 4 is 2. But if you plug in negative number, it's undefined. So you can't graph it. So this is a function that's only had one branch on the positive x-axis. And the last one is cubic root. So it is x cube root of x. And now you can do cube root of -1, so that will be a branch on the third quadrant as well as a branch on the first quadrant. It's quite similar to the square root function, except in the square root function there is only half of the branch. There's nothing on the negative x side. Okay, so you need to memorize all these functions because we can create new function with these ToolKit functions. In this book, it's called ToolKit function. In other books, it's also called parent functions. These are called parent functions. You'll notice that the trig functions and also exponential functions are not included because we are studying it in the beginning. After you study exponential function as well as trig function, there will be a few more ToolKit functions. So eventually, you would need to know all these building block functions. So that's the end of chapter 1.1.